Welcome to the channel. My name is Aisha and I'm going to be teaching you Microsoft Excel. This series of videos you're about to watch are part of our course Data Analysis with Microsoft Excel. Let's get right into it. I hope you enjoy the videos. Okay, welcome back. In this lecture, we're going to be looking at functions and formula in Microsoft Excel. So, what is a function as opposed to a formula? So, functions are a set of predefined commands that perform specific tasks. Examples are sum, count, average, to find the average of an array of numbers. Count counts all the cells that have numbers in them. Min, the minimum number in an array of numbers. Max, the maximum number in an array of numbers. So that's functions. Formulas are user-defined operations that perform specific calculations. Formulas typically use operators, such as the asterisk for multiplication, this for subtraction, addition, and then the slash for division. So I just here have an example of the difference between using a function or a formula to perform a mean calculation, finding the mean in a group of numbers. So we can see using the formula, we are actively typing A2, then the addition operator A3 to A4, and then we are now dividing by the number, which is 3. Whereas if we want to find the mean using the function, we simply write equal to average and give the range of that input, which is A2 to A4, as we see here. Just to note quickly, functions can be used in formulas. Okay, so let's go a little bit more into formula operators. So here are the arithmetic operators. So the sign, the name, and then the sample. So we have the asterisk. This is for multiplication. So if you put it in an Excel sheet, so you have 6 times 2, which is 12. This is for subtraction, addition, and as we see here, division. This percentage sign does effectively divide whatever number you put by 100 to give you the percentage over 100. And then this here is the power sign. So when you put this, so for example, this here is 3 to the power 4, which is 81. And then here are the assignment operators. So we have equal to, which is used for starting any formula or function in Excel to assign that to a cell. And then this colon here, which is used for range assignments. Colon. And here we have the relational and logical operators in Excel. So we have this sign here for AND, which you can also use to concatenate values in Excel with it, and also to combine results from various formulas and functions. So when we have greater than and less than like this is the not equal to sign in Excel. This is greater than or equal to. This is less than or equal to, and then simply equal to. So those are all the operators for writing your formulas, or rather some of the operators for writing your formulas in Excel. So now let's go a bit more into functions. Since we're finished with formulas, they're relatively straightforward. So we know what functions are, the set of predefined commands. So functions usually have arguments, and arguments are inputs into the function. So what we have is your functions, and then in the parentheses you're going to have your arguments, which are your inputs to feed into the function to perform its tasks with. Functions have a varying number of arguments, so you can have functions that require 2 arguments, that you can add up to 5 arguments. There are some that only need 1. So it really depends on the type of function and what you're trying to do. So if you want to know more about the different types of functions in Excel, you can find them all on the formulas tab, where you'll see here financial functions, logical, text functions for date, time, mathematics and trigonometry, and lookup and reference functions here. So it's the formulas tab. Now, if you remember, we did say functions have varying number of arguments required. So in Excel, we actually have the required arguments and also optional arguments. So optional arguments are usually encased in square brackets, as we see here. So this is now I have 2 examples here with the len function for strings, finding the length of strings, which you'll go more into in the string function video, and the VLOOKUP example. This will be discussed more in the lookup function video. So we can see that this function here, len, is only taking in 1 argument and it's required. So it's just you have to give it just the text that it's supposed to give you back the length of characters of. And in VLOOKUP here we have 1, 2, 3, 4 possible arguments. But if you notice the last one here, the range underscore lookup, is in square brackets. So this means that this is an optional argument. So these, while you need to impute these 3, and especially this, if you do not include range lookup and you only include these 3 and then close the parentheses and type enter, you're not going to get an error, because this is an optional argument, meaning that it has a default and the function will still run even if you do not put it in. So the last thing we're going to talk about in terms of functions and their arguments is the data types of the arguments. Now, as we know, functions can have varying number of arguments. Some may even have none. And in a case where you have multiple arguments, depending on the need of the function, those arguments could be of the same or different data types. Same thing for if you have 1. So I think the best way to illustrate this is using the sum function. So this function typically only takes in numerical data because it performs addition. So it's an example where the data type of the argument is constrained because of what the function is actually doing, so based on the need. So sum cannot take in a string or text. It has to be numerical data. Okay, so here we are in Excel, and we have here an array of numbers and then an array of text, and here we have just an array of dates, and I'm going to show you why in a minute. So for the array of numbers, if we go ahead and use our sum function there, we see that we get the sum. So we've effectively added all these numbers, and the output is 955. So that's what happened. But if we try to do a sum on these names here, which are text, see that doesn't work because we cannot sum, we can't add these together. So this is just showing you an example of, the data types for the argument depending on, being dependent on what the function is doing. Now I put in dates here just to further illustrate based on the previous lecture on data types. The way computers store dates. So some numerical functions will work with your dates. So you want to be careful, because if we do a sum on these dates, we see that we actually do get a result. And like I said, it's because of the nature of how computers store date. So if I highlight that and I change this to general, we can see the underlying numbers to the dates, which is why we're actually getting a sum. But this doesn't mean anything because the data is supposed to be a date to make any sense. So even if the function works, you need to infer what is it actually telling you, and summing dates doesn't tell us anything. Okay, so that's it for functions and their arguments. So what about functions and their returns, their outputs? So we've seen from the arguments, which are the inputs into functions, you impute the arguments and then the returns are what you get back out from the function. So outputs are also called returns from your function, and the return type refers to the data type the function outputs. Now this is very important. In the data type lecture, we learned about the basic data types in Excel, which are your string or text, your numerical, which involves your integers and floats, the date, and the boolean. So why is the data type of the return important? Well, let me start by explaining that you can give the same input into two different functions and they will output different data types depending on the nature of the function. So let's go and see this example. Okay, so here we are in Excel. Now let's see the difference. So here we have 56, which is a number. And let's see the different outputs we get by running the same value into two different functions. Let's use the len, which counts the number of characters. So here we get 2, and then let's use a is function to check if the cell is blank. So it's false because this cell is not blank, it has the value 56. But take a look here, we can see that the len brings the number of characters, so it outputs a numerical value, whereas is blank just simply checks if the cell is blank or not, so it returns a boolean value, true if the cell is blank and then false if the cell is not. Okay, so we've seen the example in Excel. So this gave us a numerical return type, and this gave us a boolean return type. So we can see that depending on the function, the data type of the return you get is different. Now, why is this important? So the nature of the return type is important because it makes nesting possible. So nesting is the act of putting one object into another. So based on that, nested functions are functions within other functions. Such that the output of the nested function is used as input into the outer function. So the logic here is the nested function will run to completion first, and then it will give its return, and then that return will then be used when the outer function runs as input. So the nested function runs first, then the outer function runs to completion. I believe the best way to illustrate nested functions is using the index and match function, which you are going to see again when we are doing our lecture on lookups. That is the end of the lecture. Thank you for sitting through, and I'll see you in the next one. Thank you so much for watching. If you enjoyed the video, don't forget to like and subscribe to the channel so you'll be notified when we have new training videos up and when our full courses are available. Bye!